With today's video, which is going to be on the mole. Now, first of all, we need to understand what the mole is. The mole is really the only standard in chemistry. By standard, we mean like in physics, kilogram, joule, meter, second. Now, a mole stands for a set number of particles, and it's what we call Avogadro's number of particles. And particles could be atoms or molecules. And one mole equals 6.02 times 10 to the 23. Not something you have to remember, because you will be given it. Now, thankfully, the mole is much simpler than that. So, we consider a mole as this. So the mole, if we look at here please, 1 mole of chromium is 52. 1 mole of nickel is 59. 1 mole of rhenium is 186. 1 mole of lithium is 7, sodium is 23. So really, as far as we're concerned, 1 mole is the same as a relative atomic or formula mass. Now, when we're looking at calculations here, as I said, there's only one real formula we need to know in chemistry, and this is it, the mole, how to calculate the mole. Now, I've put this in the forms of a triangle. So, mass will equal the number of moles times the mass of 1 mole. And if we want the number of moles, it's the mass that we are given divided by the mass of 1 mole. So, without further ado, let's get started on some of these. So, the mass of 1 mole of calcium carbonate. Fairly straightforward. So, in the formula calcium carbonate, calcium has a relative atomic mass of 40, so 40 plus carbon, which is 12, plus the oxygens. Now, as we know, when there's 3 by the base, that means there are 3 oxygens. So 1 mole will equal 40 plus 12, and 3/16 are 48. So 1 mole of calcium carbonate is 100. So that's the basic operation first of all, to be able to work out 1 mole of something. Now, let's use the formula. This next one, they want us to find 2.5 moles of sulfur dioxide. So first thing we have to do is 1 mole of sulfur dioxide. So looking at the periodic table, relative atomic mass of sulfur is 32. Oxygen we know is 16, and there are 2 oxygens, so it's 2 times 16. That comes out as 64. Now, if we look at our equation at the top here, what we want is the mass. So the mass will equal the number of moles. In this case, we're told it's 2.5 times the mass of 1 mole, which is 64. So 2.5 moles, so 2.5 moles will equal 2.5 times 64, which will equal 160 grams. Okay with that? Now, moving along with the other ones, again, just using the triangle. So, again, mass equals the number of moles divided by the mass of 1 mole. Now, in this next one, they're asking you how many moles do we have? So the number of moles. So the number of moles will equal the mass divided by the mass of 1 mole. So again, we've got to start with 1 mole of calcium hydroxide. So calcium is 40. Now, don't forget the brackets, that doubles everything inside. So we have 2 oxygens and also 2 hydrogens. Now, when we add that together, it comes to 40 plus 32 plus 2, which will equal 74. Now, what we want to know is how many moles are there. So, moles in 222. So, to get the number of moles, we divide the mass by the mass of 1 mole. 222 divided by 74. Now, if I work that out on my calculator, that will come out as 2.85 moles. Okay. Now, next type. Next type, we're just swapping the formula around. Again, we want to work out the mass of 1 mole. So what we're given this time is 3.5 moles of a substance have a mass of 350 grams. What is the mass of 1 mole? So basically, we want the mass of 1 mole. So the mass of 1 mole, if we look it up, 1 mole equals a mass divided by the number of moles. So in this case then, one mole will equal 357 divided by 3.5. Now, 357 divided by 3.5 comes out as 102 grams. Right. Now, the next bit is where they often start playing with indices. So, in this, it's working out the mass of 1 atom of magnesium. Now, from the periodic table, the relative atomic mass of magnesium equals 24. So we know that 6.02 times 10 to the 23 atoms have a mass of 24. So 1 atom will equal the relative atomic mass, 24, divided by 6.02 times 10 to the 23. And that will come out as 3.99 times 10 to the minus 23. And it's minus because remember you're dividing by 10 to the 23. So just remember that. Now you can do exactly the same again with 1 molecule. So first of all, again, work out 1 mole of CO2. So carbon we know is 12. There are 2 oxygens, which we know are 16 each. So 2 16s are 32. So 1 mole comes out as 44. Now we know that 6.02 times 10 to the 23 particles or molecules of carbon dioxide have a mass of 44. So 1 molecule will equal the mass of 1 mole, 44, divided by 6.02 times 10 to the 23. And when we work that out, that's going to come out as 7.31 times, again, and don't forget, minus 23. Okay, so careful with those indexes. Right. And we've got one last thing to do for the time being. These are with gases. And again, we have a standard here. 1 mole of any gas at standard temperature and pressure occupies 24 decimeter cube. And for that we have another triangle formula. So the volume of any gas equals the number of moles times the molar volume, and the molar volume is always 24 decimeter cube. So without further ado, what is the volume of 2 moles of hydrogen? Now 1 mole we know is 24 decimeter cube, so volume equals the number of moles times the molar volume. So 2 times 24 equals 48 decimeter cube. Now, next part. This is when you're given a volume and they want to know the number of moles. So, number of moles equals the volume divided by molar volume. So, in this case then, moles equals the volume we're given, which is 7.2 decimeter cube, divided by 1 mole. And 7.2 divided by 24 comes out as 0.3 moles. And lastly, there's this idea of a two-step calculation. What is the mass of 50.4 decimeter cube of nitrogen dioxide? So the first step always is to work out 1 mole of NO2. Now, nitrogen is a relative atomic mass of 14. Oxygen, as we know, is 16. So 2 16s are 32, plus 14 is 46. Now, if we've got a volume, what we need to do is work out the number of moles. So moles NO2, and we know the moles, to work out the number of moles, that is the volume divided by the molar volume. So the volume we're given, as you can see, is 50.4. The number of molar volume is 24. So let's work that out. 50.4 divided by 24 equals 2.1 moles. Now, we've already worked out that 1 mole is 46. So if we want the mass of 2.1 moles, so mass will equal the number of moles, 2.1, times the mass of 1 mole, 46, and times 46 equals 96.6 grams. Now, moles of gas is easy to work out because the molar volume always stays the same at 24 decimeter cube, and you're always told that. That's the first thing. All molar calculations, this is exactly the way they do it at A level and degree level. The only difference is the number of places of decimals that they go to. We go to 3 significant figures. At universities and sixth form colleges, they go to maybe 4 significant figures or even 5. So I hope that's clear. The only way to practice molar calculations, to be secure with molar calculations, is to practice them. So that's all for now.